Hello friends, good morning. Myself Professor M.H. Chennaiya. In today's video, we are going to draw the development of a square pyramid which has its base edges measuring 40 mm and the height of the solid is 70 mm. And here the solid is resting on HP on its base such that two of its base edges are equally inclined to VP, or all the four edges of the base are equally inclined to VP, or all the four triangular surface equally inclined to VP, and obtain the corresponding top and front views of the solid. So I place like this, and if you look from the top print, you will see the base ABCD with these two edges at an angle of 45 degrees to VP. This is what I have shown here, and this is how it appears. In the top view, you can see the vertex O, and that is connected to all these corners A, B, C, and D by these four slant edges. So friends, I have got this top view, a square. I produce all these points to the front view, mark the height on this axis which is equal to 70 millimeter right here, 70 mm, and produce all these points from the top view to the front view, and you get A produced here gives you A dash, C dash, B and D coincide here. Here the axis of the solid OO1 or O dash O1 dash is perpendicular to HP. The positioning of the object is over. Next comes placing of the section plane. Friends, you can see here the object is cut by a vertical section plane passing through the vertex. Vertex is O and inclined at 45 degrees to VP, 45 degrees to the vertex and passing through the vertex. So this is the section place I have marked. This is the vertex. It has to pass through the vertex and it should make an angle of 45 degrees with the VP. Inclination to VP can be seen only in the top view. So friends, I have drawn the front view of the solid. Top view also we have drawn, and next comes what is called drawing the development of this portion, either this or this. Since I have shown like this, we will draw the development of this part. Friends, we should remember here that since the section plane is passing through the vertex and this is at an angle of 45 degrees to the vertical plane, this section plane SS is going to cut the solid base at this point, AD here and BC, exactly in between BC and exactly in between AD. So this point is very, very important. Friends, now if you see the front view of the solid, the last line O dash C dash, the last line O dash C dash represents the true length of the slant edge. You can ask me how. You can see here friends, the top view of this line is parallel to VP and hence this gives you the true length. And using this true length, I am going to mark a sector of this length equal to the TL obtained from here and draw an arc here. On that arc, I am going to step up four divisions, each of 40 millimeter, 40, 40, 40. So we are going to have four triangles on the lateral surface of it, that you can see here. 1, 2, this is 3 and this is 4. So there are four triangular surfaces on the lateral surface of the pyramid. Now friends, let us see how to obtain the points where the section plane is cutting the solid. Friends, I have explained before that the base edge AD is cut exactly in the center of AD at the bottom, AD center. So let us mark here, this is A, B, sorry, it's not E. So this is totally removed. So since this is removed, you have to start from that only, you're right. So this is going to be A, B, C, D, finally A. Remember friends, the last two lines will have the same numbering, OA, OA or OB, OB, whatever it may be. Now friends, there are 3 points, one on the base edge AD, one on BC and the vertex. So on AD, exactly in the center, on AD, exactly in the center, we mark a point. Exactly in between BC, we mark another point. Exactly in between B and C, we mark. So one point is here, 2 points. Vertex is here. This is another point. So friends, basically, you have got what is called 3 points only. One here, second, and third. And remember, the slant edges OC and OD are not touched. They are existing. OC and OD. Friends, what I do? I am going to join this OD completely, OC also completely, and these 2 points are to be joined to the vertex. This is one point, this is the other point. This is the other point. So when this is there, you are going to have this point existing, this edge is there, and you can see here OA and OB are totally removed. These two do not exist at any cost. When these do not exist, this base edge portion also does not exist. So friends, you will be having in the development of this part B, which is given by this part. That is, if I call this as point 1, 2, 3, 1, 2, 3. This is point 1, say 1, vertex is 2, here this is 3. 1, 2, 3 points. Here you can see in the development, this is what you are going to get. That is half triangle, full triangle. So that is will give you development of P, the portion between the vertex and the half. And if you closely observe the top view, friends, in the development as a check, you are going to have only 2 triangles. That is one full triangle ODC. Yes, ODC is one triangle that is retained. Next, we have got here half triangle here, half of OAD, half of OAD. OAD half. So this half. And similarly, you are going to have here OC this point. So you are going to have this triangle also. Friends, you can observe here. In the development, finally, there are going to be one full triangle OCD, half triangle for this, another half triangle here. So totally in the development, you will have all put together 2 triangles because this is totally removed. So if you want to draw the development of this, you are going to get once again 2 triangles in the development. Friends, I hope the presentation was interesting. Please go through the complete video without skipping any part of the video in between. And friends, if you like this video, do share this video with all your friends without fail. Thank you very much for watching my YouTube video. Have a blessed day. This is Dr. M.H. Chennaiya signing off.